Good morning. In our previous video, we had done the concept of slope of a straight line. I'll just do a quick recap of that. A line can be uniquely identified if along with a point you know the direction of a straight line, or if you know 2 points lying on the straight line. Now, slope of a line. Slope of a line is defined to be, it is usually denoted by small m and is defined to be tan of theta, where theta is the inclination of the line which it makes with the positive x-axis. So slope is m equal to tan theta, where theta is the inclination. By inclination we mean the angle which the line makes with the positive x-axis measured in the anti-clockwise direction. Now, in case 2 points are given to us, then having coordinates x1, y1 and x2, y2, then the slope of the line is defined as y2 minus y1 upon x2 minus x1. That is, it's the ratio of the difference of the two y coordinates to the difference of the corresponding x coordinates. Now let us continue with further with this concept of slope of a line, and let's do some more results. Now the next result which comes is condition for parallelism and perpendicularity of lines in terms of their slopes. Okay, now given two lines which are parallel to each other. So let's consider two lines L1 and L2. We are already aware that if two lines are parallel to each other, then they will make the same angle with the positive x-axis. So the inclination of the two lines would be the same. So let L1 make the inclination theta 1 and L2 make the inclination theta 2. Clearly, as L1 is parallel to L2, we have theta 1 equal to theta 2, which will give us tan of theta 1 equal to tan of theta 2, which will give us m1 equal to m2. And so we conclude that L1 parallel L2 implies and implied by m1 equal to m2, and that is that if the two lines are parallel, their slopes would be equal. Okay, now the next one is consider, let L1 be perpendicular to L2. Now in this case, let's take the figure like something like this. So if we are given a line which makes an angle theta with the inclination of the line L1 is theta, and since it is perpendicular to the other line, so let the other line be L2. So the inclination of the first line is theta 1, the inclination of the second line would be theta 2. This is the x-axis and this is the y-axis. Now, so from this triangle, let's call these points as A. Let the point of intersection be B and let this be C. So the two lines will make an angle, a triangle ABC. Now in this triangle ABC, this is 90 degrees, and by the concept of the exterior angle is being equal to the sum of the two opposite interior angles. So what we get is theta 2 is equal to 90 plus theta 1, because the two interior opposite angles are 90 degrees and theta 1. So we know that theta 2 will be equal to 90 plus theta 1. So tan of theta 2 will be equal to tan of 90 plus theta 1, which is equal to, by the identity we have, tan of 90 plus theta 1 will be equal to minus of cot of theta 1, which is equal to minus 1 upon tan theta 1. But tan theta 1 is equal to the slope of the first line, and tan theta 2 is equal to the slope of the second line. And so we have m1 m2 equal to minus 1 upon m1. This is one result, which can also be written as m1 m2 equal to minus 1. And so we arrive at a very important result, that if the two lines are perpendicular, the product of their slopes would be minus 1, or slope of one line would be the negative inverse of the slope of the other line. Whereas in case the lines are parallel, we have the slope of the two lines would be equal. So let's quickly write it again. Thus we have, if L1 is parallel to L2, this implies and is implied by m1 equal to m2, whereas L1 perpendicular to L2 implies and is implied by m1 m2 equal to minus 1, which is also equal to m2 equal to the negative inverse of the m1, that is m2 equal to minus 1 upon m1. These two are very, very important results which will help us solve many problems. Okay, now let's find the angle between two given lines. Now we are already aware of that given any two lines, there could be two cases which arise. One is either they are parallel or they intersect. Okay, now in case of intersecting lines, there could be two cases which arise, that they could intersect making a pair of angles, one of which is acute and the other one is obtuse, or they could intersect making an angle 90 degree with each other. Okay, so these are the three cases which we will have. So L1 is parallel to L2, we have already considered. L1 perpendicular to L2 also we have considered. So now let's take the general case of two lines which intersect at each other, making a pair of angles, one of which is acute and the other one is obtuse. Now, so let's start with this. So let us consider two lines L1 and L2 making angles theta 1 and theta 2 respectively with the positive x axis. Let L1 and L2 intersect at making an angle alpha with each other. Okay, so let's consider that case. What do we get? We have two lines. Okay, so let this be L1 which makes an angle theta 1, and let this be L2 which makes an angle theta 2. Let the angle between them be alpha. So clearly alpha is theta 2 minus theta 1. So over here we can clearly see that alpha is equal to theta 2 minus theta 1. Okay, so tan of alpha will be equal to tan of theta 2 minus theta 1. But we have the identity for the tan of difference between the two angles as tan theta 2 minus tan theta 1 upon 1 plus tan theta 2 tan theta 1. Also, we know that since L1 makes an angle theta 1 and L2 makes an angle theta 2 with the positive x-axis, so we have M1 equal to tan theta 1 and M2 equal to tan theta 2. So substituting, we get tan alpha equal to M2 minus M1 over 1 plus M1 M2. This is one result which we have got. Now we come to one very important thing, that we know that when two lines intersect each other, they will always make a pair of angles. They will always intersect, making two angles. That is, this is one angle and this is the other one. But out of the two angles, one would be acute and the other one would be obtuse. Now usually, unless and until asked for, we always report the acute angle between the two lines. Okay, another point to be noted is that tan of an acute angle is always positive, whereas tan of an obtuse angle is always negative. And so to find the acute angle between the two lines, what we do is, thus acute angle between two lines L1 and L2 is defined as tan of alpha would be the modulus of M2 minus M1 upon 1 plus M1 M2. And so it is a very important point to be noted that we always take the modulus of this, because because we don't know whether M1 is bigger or M2 is bigger. We simply take any line, slope of any line as M1 and the other one as M2, and then we find tan theta. Whatever result we get, we take the modulus and which makes it positive, and so the acute angle will be found out using the modulus of M2 minus M1 over 1 plus M1 M2. Thank you.